In this video, we're going to talk about sample space with compound events. Just to review what sample space is, it is the possible outcomes for an event. So if we look at this spinner right here, we have red, green, and blue. And on this coin, we have heads and tails. Normally what we would do is separate those and just say red, green, blue for the spinner, heads and tails for the coin. But in compound sample space, we want to push both events together. So that's the difference between simple and compound. Simple is 1, whereas compound is 2. So in this particular sample space, we have the spinner where we could spin a red, a green, or a blue. So those are the possible outcomes or sample space for the spinner. But in a compound event, we want to pair that coin with the spinner. So what we do in a tree diagram is we branch off to show the next sample space for the second event, which is heads or tails for the coin. So I could possibly spin a red on the spinner and then flip a coin and land it on heads, or I could spin a red and spin or flip a tail. I can do the same thing with the green, so head or tail, and the blue, so head or tail. So if you look here, I have an outcome that is a possible outcome of 6. I have a red head, a red tail, a green head, a green tail, a blue head, or a blue tail. So if we count all those up, that is 6 possible outcomes. So the sample space for this tree diagram would be 6, and here's why. We have 3 outcomes on the spinner, 2 outcomes on the coin, so when we multiply those together, we get 6 possible outcomes altogether. In this next, we have that they want us to build a table. So we do have again the spinner where it is a red, green, and blue, but now we have a die, and there are 6 outcomes on a die. So here when I build my table, just going to kind of stretch this out a little bit, I have the outcomes for the spinner, which are red, green, or blue again, and then I have the outcomes for the die down here, which are 1, 2, 3, 4, 5, and 6. So now when I set this up, I can either spin a red and land on a 1, so I have a red and a 1, or I could do it with a 2 or a 3, and so on and so forth. So I'm just going to do this first row right here. So far there are 6 options that can be done with a red and die combination. The next one with the green, I have a green and I could land on a 1, or a green and land on a 2, so on and so forth. And then last but not least, I could land on the blue section and then land on any of these numbers for the die. So I have a blue 1, blue 2, blue 3, so on and so forth. So again, if I were to count all these up, I have a total of 18 outcomes. And again, here's why. I had 3 on the spinner, 6 on the die, so when I multiply those together, I get a total of 18 outcomes. Any one of these outcomes will do in a table, and so it just shows you another way of doing it. In this next example, we are dealing with a list. So we have that they have a blue and a red pair of jeans, a green, white, and yellow shirt, an orange hat, and a pink hat. So what you do with the list is you just list it out. I can have the blue colored jeans, a green shirt, and an orange hat, or I can have the blue jeans, the green shirt, and the pink hat. I can have the blue jeans, white shirt, orange hat, blue jeans, white shirt, pink hat, blue jeans, yellow shirt, orange hat, blue jeans, yellow shirt, pink hat. So that's all the possible outcomes with the blue jeans. So when I look at the red jeans, it's pretty much the same thing, except everywhere there was a blue, I substitute it with a red. So red jeans, green hat, or green shirt, orange hat, red, green, pink, red, white, orange, red, white, pink, red, yellow, orange, and red, yellow, pink. So if I look right here, I have 1, 2, 3, 4, 5, 6 outcomes with the blue jeans, 1, 2, 3, 4, 5, 6 outcomes with the red jeans, and that is a total of 12 outcomes altogether out of Sarah's closet. So again, if I were to look at this, I have 2 jeans, I have 3 shirts, and 2 hats. When I multiply all of these together, I get 12 outcomes, which matches right here. So hopefully this helps you with compound sample space.